Hello everyone. In this video, we're going to look at the Java class hierarchy and the usage of interface. The sample project we're going to use is a roster management project. We're going to implement two rosters. One roster is for student, another one is for faculty. I have three class hierarchy here. We have the person hierarchy. Student and faculty, they have some common traits, common attributes, and common behavior. So I designed this class hierarchy so we push up all the common attributes and behavior into person class. Then student and faculty class are going to concentrate on implementing what's special about the student and what's special about the faculty. So that's one class hierarchy for the data part. And I have another class hierarchy for the list part. For the roster, we need to model a collection of students and a collection of faculty. And for those collections, for sure they have common attributes and behavior. So we designed the second class hierarchy, push up all the common attributes and behavior into person list. Then student list and faculty list only implement the difference, what's special about those two. And also I have the third class hierarchy is in charge of the user interface. We will have a user interface for student roster because student roster could have add, remove, and some other menu item, and faculty roster could have some other menu item, and they could have specialized menu item. And so again, we use a class hierarchy to be in charge of the user interface. And here, this is not a class hierarchy, this is an interface, the usage of interface. You can imagine interface in Java is 100% abstract class. So interface only specify a contract. It only has abstract method. So when I say controller is going to implement runnable, that means whatever I specify in runnable, the method, controller need to give implementation. If controller itself is an abstract class, it doesn't have to implement the method specified in runnable. It could be student controller or faculty controller. They go ahead and implement that method if they're not abstract. If this one is abstract, it can choose, I'm not going to implement it because I'm an abstract class. So that's a class hierarchy for the roster project. We have the data hierarchy, we have the collection of data hierarchy, and also we have the user interface hierarchy. Now let's take a look at the Java code in Eclipse. So let's take a look at the first hierarchy first, person. So you see, person class is an abstract class. That means you can never create a person object. So this class only purpose is to serve as a parent. You cannot instantiate an abstract class. The concept is the same as C++ abstract class. So you declare it to be abstract, and usually an abstract class is going to have abstract method. Now let's take a look at the person's class design. The attributes we have, to simplify the matter, we only have one attribute, that's ID. So student will have ID and faculty will have ID. Like at PCC, we all have G number here. So that's a common attribute. All right. So we have the constructor, the default constructor, and the constructor that takes in an initial ID. And we have the get ID, set ID to manipulate that attributes. And we override the toString method to include the ID information. Here we also have an abstract function called pay parking. Once you have an abstract function here, that means all your subclasses, if they're not abstract themselves, then they have to give implementation for pay parking. The good news is this guarantee all the subclasses of person will know how to do pay parking. So that makes your client code as long as it's a person, they can invoke the pay parking method. So this is clearly a dynamic bonding, and we don't have the implementation here because faculty or students, they have their specific way to pay parking. So it's an abstract method here. So that's a person class. Now let's take a look at the student class. The student class added one attribute, that's a GPA. So student class, let's take a look at the class hierarchy. This is how you say I'm a subclass of my parent class. So you say extends class student, extends person. So that means every student, they have ID defined in person. They have ID, but it's a private in-person class. So student class doesn't have direct access to this ID because it's private. All right, and now let's come back to the student class. So on top of ID, it has GPA. So we provide to get GPA and set GPA, the two method, service method for the GPA, and we also have the constructor here. And pay attention to the constructor invocation sequence. Just like in C++, the object, when an object is created, the constructor invocation sequence looks like it will go up the class hierarchy, initialize the parent first, then come back to initialize itself. So for student, when a student object is created, it comes to, if it's a default constructor, it will first invoke the default constructor in the superclass, which is a person class, and after it comes back, it will initialize whatever special about student. So that's a GPA. Same here for the second constructor. When they invoke this constructor, they could give the ID and the GPA. In order to initialize the inherited ID part, you don't have direct access to ID, so you have to ask your parent to initialize itself by invoking the constructor that pass in the ID. This is how you invoke the constructor. You say super parentheses. So that's a constructor invocation sequence, and the GPA part we take care of them by those two service methods, and we also override the toString method. The toString method, we first invoke the superclass toString to include the ID information, then we add the GPA one. And also remember, student class isn't an abstract class. That means student class has to implement the abstract method defined in person class, which is pay parking. So we just display a message about pay parking here. So that's a student class, and the faculty one is very similar, such as faculty has a step instead of a GPA, so all the other implementation is quite similar. Now let's take a look at the second class hierarchy, the list hierarchy. So now let's take a look at the person list. Again, person list is an abstract class, which means it only serves as a parent class. You can never create a person list object. Most likely, if a class is abstract, it contains abstract method. So for example, we have two abstract methods here, load from file and save to file. So now let's take a look at the person list class. We have a list of person. So a list of person, it could be a list of students, it could be a list of faculty, and we also have a file name. So most likely that file name has that file contain data about the collection of person. So those two things. Let's take a look at the constructor. Inside the constructor, you create the list for the list object for the person list. So when you do this in Java, you don't really have the object. In Java, we always do new something, the type to create the object. Otherwise, you don't have objects there. So we create the object. It's an empty list now. And for the other one that takes in a file name, we create the object and we invoke the load from file. Okay, so again, this load from file is an abstract method. That means we don't know how to load from file in the parent class, because when you load a collection of students or a collection of faculty, they have different attributes, so the load code will be different. The same thing for the save. So here we just specify both faculty list and student list should provide the implementation of load from file and save to file. That's why we make it abstract. Okay, the add and the list all, those ones, add and list all, those ones are the common behavior of faculty list and student list. So to avoid code duplication, we provide the implementation in the parent class. So that's a whole idea about using class hierarchy so that you don't duplicate the code and it's easier to maintain that way. So that's about the person list. Now let's take a look at the student list. Student list, again, for the constructor, you first invoke your parent's constructor, then you come back to invoke yourself, all right? And now you see for student list, since it's not an abstract class, it has to implement the abstract method defined in person list, which is load from file and save to file. Those are specific to student list. So that's the second class hierarchy. Now let's take a look at the last class hierarchy, which is a controller hierarchy. It's trying to model the manual part. Now let's take a look at the controller class. And again, it's an abstract class, so you cannot create the object of controller. You can only create the object of subclasses of controller. And here, let's see, we say implement runnable. Once you do this, you are obligated to implement whatever is defined in runnable. So now let's take that's an interface. Now let's take a look at the runnable here. Inside the runnable, there's only one method called run. So that's interface. What's contained in the interface is just the contract. The interface could have a bunch of abstract method, public abstract method, because they're all public abstract, so we don't really say it, because by default they're public and abstract. There's no implementation. Interface is just a contract. Say, whoever want to implement runnable, you have to provide implementation for run, unless you are abstract class as well. So now let's take a look at the controller class. After it's sum up saying, I'm going to implement runnable, then that means you have to implement run. So here we have the run method, which is just a menu-based run method. You display menu, you get the command, then you execute the command display menu. So that's a loop about the menu-based user interface. All right, so let's see. After you sign up to implement runnable, the benefit will be any object of controller or its subclasses, they can be used as a runnable object as well, because for sure they're going to implement the method defined in runnable. So the type information for controller object, all of a sudden they have another type information that's runnable. Which means wherever they require a runnable object, a controller object will do. And in this case, controller is an abstract class. You won't have a controller object, but you will have the subclass of controller object. But it is a relationship. Okay, so keep that in mind. That means wherever we need a runnable object, a controller object or its subclass object will do. Okay, so for the controller class, we have a person list, because it's a kind of the driver class for the database. So it has a person list, and it also has a scanner object to read the input from keyboard. So that's a constructor to do the initialization, and we have two abstract methods defined here: display menu and execute the command. Because this controller object here, it doesn't know how to display menu or execute the command, because it's based on, are you a controller for student database or are you a controller for faculty roster? Because for different different menu. They have different menu and they have different way to execute their command. So that's why you make them abstract and you demand your subclasses to implement those two methods. And we have some common things like get command and run, so it's implemented here in the controller class. Now let's take a look at the student controller class. Student controller class, let's see, it doesn't have added any data, it just inherit from the controller class. So if you remember, what we inherit the data that's a person list and the scanner object. So let's take a look at the student controller here. Now let's see the constructor. Again, you're going to initialize your parents first, then it's going to create a new student list, and display menu, this is specific about student roster. Execute the command, this is specific about student roster. Again, like how you add a student, you need to first get student. Let's take a look at the add student. You need to first get student, then from user, then add it to the list. That's a execute the command one. So this is a student controller class that serves as a manual object for the student roster. Now let's take a look at the main class, which is the entry point of the application. Inside the main class, we have the static object. So the reason it's static is we want to use it in the main function, which is a static function here, static method here. So we have a static object here, and inside the main function, we need a list of runnable. So you see, a list of runnable. So as long as you give me runnable, this will be fine. So when we add, we say student controller. Remember, controller class implements runnable. So controller class is a runnable. So student controller is runnable. So we add the student controller, we add the faculty controller. And you can imagine if it's a graphical user interface, you can imagine we have the main page of the application. Maybe we have two tabs. One tab is for student roster manager, another one is for faculty roster manager. If you click on the student roster manager, it will show you the options about what you can do about the student roster. If you click on the faculty tab, it will show you the faculty roster manager. So now we have the list, a list of runnable, which is a controller object here. Then we have the menu-based user interface, get the choice, and then the major thing here is after user choose either the student roster or faculty roster, you're going to ask that roster to run. So that interface object. So that's a controller object. You just say run because they're all runnable, so they have a run function there, run method here. Okay, and how about now I'm going, so another thing I want to point out is inside this main class, all the method here, the helper method. So you see this is a main method, there's a helper method, display menu, and get choice. Those two are static as well, because inside the main function, if you want to invoke another method, they have to be static as well. Otherwise, you have to create an object of this main class, then invoke those instance methods. Without static, that's instance method. You can only invoke an instance method from an object of this class. Since we don't want to create an object of main class, you can do it that way. If you want to create an object of main class, you can make those ones instance method. But here I don't want to. Those are just actions, so I make those methods are all static so that we can invoke them inside the main function. All right, how about let's go ahead and run this application so that you get some idea about how this fits together. So All right, so here's the main menu. It says please enter your choice. You can either enter the student roster manager or faculty roster manager or quit. So if I choose student roster manager, then it shows me the student roster menu. I can add a student. Here I just want to do a listing, list all the students here. So I have some preloaded student there. And if I want to quit the student roster manager, I can just say quit. It takes me back to the main page, the main menu. And now if I want to say, now I want to run the faculty roster manager. They look very similar, but in reality they could be quite different. So I'm going to do a listing, then it shows me the faculty roster. Then if I quit, it takes me back to the main menu. Now if I say quit, I just quit the application. Alright, so that's a sample project to show you how to use multiple class hierarchy and how to use interface. So the 3 hierarchy, let's take another look. The 3 hierarchy, we have one hierarchy for the data, we have one hierarchy for the database, like the collection of data, and we have another hierarchy for the user interface part. And here we also use the idea of interface. Thank you.